So for the next model, it's going to be similar, but a little bit different. This is both an internal and an external flow problem. And we are going to be, in addition to looking at quality of flow, we are also going to be looking at temperatures, since this is a heat exchanger problem. So what do we have in this model? So this is an adhesive applicator, and if I display all my callouts, you can see very quickly what's going on here in the model. So we have a channel running through this block, and we have one fluid entering at a velocity flow rate, pushing up against a pressure. And then we have an inlet volume flow for second fluid volume. And we have two fluid subdomains in this model. So in this case, we have a glue, so it's a pretty viscous material, pretty dense, and that is this fluid domain. And then the second fluid domain are hot water runners that are keeping this applicator warm. And if we zoom out, we see that I'm also running this as an external flow analysis. So convective effects of air flowing around the tool are being accounted for, because in addition to looking at how the fluid is flowing through the model and the temperature drops, I also want to look at the temperatures and the comfort parameters surrounding this applicator. So as we walk down the feature manager, what goals do we have in this simulation? I'm asking for temperatures on the inputs and the outputs of both of my fluid domains, and therefore I've got a hot side delta temperature, a cold side delta temperature, and a hot side pressure drop, very similar to what we did with the CV model. And I like working on models like this because I wasn't quite sure what to expect initially. And you know, my goal is to keep my adhesive within the temperature range, and also to have good flow and to be efficient. So let's load up our results. So the main metric I'm interested in is the temperature and flow characteristics of the glue, given the hot water that I'm running through the system to try to keep the glue warm or at a consistent temperature, but not too hot. And this is my baseline study, the first tryout. And we see that I've got a fair amount of recirculation going on here, and the temperature of the fluid or the glue adhesive is not very consistent. It is dropping as we pass through the tool, but yet it's getting pretty hot here at the top, close to the inlet. We can also look at this in a cut plot format. And one thing I like about flow is that I can easily change my scale without having to go back into a dialog box. And then anytime I've got a plot up, I can go ahead and go to the command manager and probe to get values at specific locations. So my hot water has been entering at 250 degrees. And my glue is entering at 80. and in the center, it's just barely warming up. So what are my other options, or what parameters do I have here to increase or create a more consistent temperature across my adhesive? And I can change the flow rates of my incoming hot water. I can adjust the flow rate of my adhesive to some extent. But what I found was the key here was decreasing the amount of heat lost to the atmosphere. So I have another version of this model where I insulated the outside of the model. And we can look at our solid materials. So everything in here is steel by default. And then I picked the outer surface that's around the steel, and we put a 1/4 inch of fiberglass insulation. And so now I can go ahead and take a look at my flow trajectories. And we want to compare these back to our baseline. And I want to do an apples to apples. So we can use our compare function. And in this case, instead of comparing the goal plots, I want to compare the active scene between my insulated and my baseline. So as we see here, Flow has automatically created the pictures of the current scene that we're looking at. All our plots and everything are equal, so we're comparing apples to apples, and we're getting a much better uniform thermal distribution across our adhesive. And in this case, I might my next phase would be rethinking the orifice that I'm pushing the flow through here to avoid this recirculation. And we'll change this over to spheres for a quick animation. Okay. And are there any questions? I can open up, I can take a look at the chat panel if there's any questions right now.